Welcome, ladies and gentlemen, to Lesson 4.3, I Can Find Rates of Change, starting on page 198 of your Glencoe Course 3 textbook. This is going to require you to still remember what a ratio, a rate, and a unit rate are. So make sure that you have your vocabulary out and use this as a reference tool as we go. Make sure you're pausing when necessary and going on and making sure you're not chasing to write notes down, but you're following along and listening and then checking your work. So a rate of change is a rate that describes how one quantity changes in relation to another. So we're looking at a change of rates, okay, rate of change. So we'll look at some positive rates of change and then we'll look at some negative rates of change. So if Alicia had 32 entries in her email contact list at the end of 2007, we're going to use the information on the right to find the rate of change in the number of entries in her email between the years 2004 and 2007. So if we add it on, the table in your book shows more like this one. So we're looking for entries per year, not year per entry. So you always want to think of what am I comparing my Y to my X value. Okay? You're dependent to your independent. So I'm going to look at what is the difference, and difference is subtraction, in the change from now, 2007, well, the most recent year, to the latest year of 2004. Okay? So I always think of the rate of change is the new minus the original over the new minus the original. So I go the newest to the oldest to find that. So what we do is we take 2007 minus 2004, and then 62 minus 10 over that. So when we do that, and it's really written like this, 62 minus 10 over 2007 minus 2004. When I subtract, I end up with 52 entries in 3 years. That's the rate. I really want to change it to a unit rate to find out how much it changed per 1 year. And so I get approximately, when I plug that into the calculator, 17.33 repeating. So it's approximately 17 entries per year. So what this means is, and it's very important to record what you have and understand it, since the rate is positive, Alicia's email contact list increased or grew at an average rate, of about 17 entries per year between the years of 2004 and 2007. So in that description, we reported that it was a positive change. That means our contact list grew or increased. By how many and in what time frame? Very important to be specific. So you may want to pause here and try on your own, or maybe you want to watch me set it up and then try. Whatever you do, just make sure you are following along and being engaged. Nope, don't look over there. Come back to me. So, here I'm looking to find the rate of change in the height of years. So I'm comparing height to years. So really, how much did you grow in inches per year? So I really want this in inches. My table's already set up for me. So I'm going to do my rate of change is the change in the height. So now they're at 58. Ramon's at 58 inches when he was at 51. So if I subtract the new and then take the old away from it, I'm going to find out how much he grew. From now he's 11 to then he was 8. So that means he grew 7 inches in 3 years. So I want to know, on average, how much did he grow in 1 year? So that's 7 inches, 3 years. To find a unit rate, it's really like I'm dividing both the top and the bottom by 3. And 3 goes into 7 2 times, with one of the 3 remaining. So it's 2 1/3 inches per year that Ramon grew. And I like to use fractions because I'm normally going to, in inches, talk with fractions rather than decimals. This is something you probably just want to listen and follow along with, and then you'll record some things at the end. So this is just a graph example here from example 1 of Alicia's email contacts. And the data points are connected by a broken line. That broken line just shows that there was no data between the points. We were given data this year, and this is our assumed change. So, a positive rate of change is shown by a segment slanting upward, left to right, and a negative rate of change would be shown by a line segment slanting downward, left to right. So we always read left to right. So if something's going down left to right, that's negative. Whereas if something's going up left to right, that's positive. So you are going to want to put this in your notes. So rates of change. A rate of change is positive. That means that it's increasing, and that's shown on a graph by slanting upward, left to right. Whereas if a rate of change is negative, we actually call that being a decrease or going down, just like the line does, left to right, it goes down. Sometimes there is no change or a rate of change of 0. That means that there's no change. So here, so maybe someone took a test, didn't study, and didn't do anything for their retake, and they still got the same score. Maybe they failed again or got the exact same score. That would be a rate of change of no change, 0. There was 0 improvement and 0 decline. So rate of change of 0. Make sure you have those in your notes. Up next, now talking about a negative rate of change, what does that look like? So we're looking at computers, and this is old data from before you were born. The graph shows the average cost of personal computers for the years of 1997 to 2002. Find the rate of change in cost between 1998 and 2000. So now we're not going to be looking at all of this data. We are only looking at the rate of change between 98 and 2000. So we really only need the data from here to here for this problem. So make sure that you're reading the directions. So the first thing I'm going to do is make a table. And I'm going to be comparing the year and dollars. But I'm not going to do year per dollar. I'm going to do dollar per year. That's what I really need to find out. So I record that information. Remembering this is my X and this is my Y. And this is really the change in Y over the change in X. So we're going to use the data to write a rate comparing the change in the cost to years. So like I just said, cost per year. Notice how 1,000 came first because that was most recent in 2000. Oopsie. Something you'll also notice is that these ordered pairs stayed together. Notice 1,000 is right above 2,000, and that stays there. 1,398, they should stay in order with each other. So the cost changed from 13,000 to 1,000, so it went down, and the year frames changed from 98 to 2,000. So again, we went new minus original. What I notice then is I get a negative 300 over 2, and to find the unit rate then I get negative 150 over 1. The meaning, which is very important, is that the rate of change was negative $150 per year. That means it's negative because the average cost of a personal computer decreased in that time frame, and this is shown on the graph because the line segment is slanting downward left to right. So we could have assumed, oh, right here, we see that the cost is going down left to right, so it's probably going to be a negative change. Using that same information now, and that same chart, now they're asking us, find the rate of change between 2000 and 2002. So now we're looking from here to here. Very important to know what you're looking at. So I'm going to do the rate of change. I might want to make a table. So this time I'm going to do cost, and then the year. So the cost 2000 was 1,000. And the cost in 2002 was 855. So rate of change, I'm really doing change in y over the change in x. So I'm going to do 855 minus 1,000 from 2000 to now to then in 2000. When I subtract, I get negative 145 in 2 years, which simplified to negative 72.50 per 1 year. So if I were to describe what that rate of change means, as shown on the graph, is that it's a negative rate of change because it's slanting downward. And it could say that it means the personal computers are less each year between 2000 and 2002. Obviously, your writing will be a little bit better without a stylist. So last little bit, and now we're going to talk about how does a webmaster use math in their career. So internet, the graph here shows the number of internet users in the United States. Again, a long time ago, so this has probably really increased. So we want to compare the rate of change between 2002 and 2003 to that compared to the rate of change 2004 and 2003. So you notice that the segment from 2003 to 2004, here to here, is steeper, appears steeper than from 2002 to 2003. So we could assume that the rate of change from 2004 to 2003 was greater than that change, but we can check by actually doing the math. So 2003 to 2002, we record our data. We see that in 2003, these are ordered pairs, so it gives us that. We're at 161, whereas in 2002, we were at 158. So we increased by 3 in 1 year, unit rate of 3. Whereas 2003 to 2004, we went 190, this ordered pair, compared to this ordered pair. Looks like we went up 29 in 1 year. So, since 29 is greater than 3, the rate of change between 2003 and 2004 is greater than the rate of change from 2002 to 2003. Last one, you can give a try. So if we use the table to make a graph of the data, during which 2-year period was the rate of change in oil production the greatest? So we're going to make a table and then explain. So we would make our x's and y's. We're going to compare barrels per year. So we have our x-axis and our y-axis. Recorded that data. These are ordered pairs, if you remember. So in 1996, 478 and 1/10. So then they were marked there, and so on and so forth. So doing those ordered pairs in each spot. And then just from the steepness, we can tell that right here was a big drop between 98 and 2000. So the rate of change between 1998 and 2000 is the greatest, whether it's positive or negative. It still was the biggest amount of change than any other 2 periods because it was the steepest. Okay? This just says something about absolute value. When comparing negative rates of change, compare the absolute values of the number. So the distance from 0, so it's always going to be a positive comparison. So that's a really big drop-off, even though it was a decrease. It was changed by the most. I hope this was helpful for you, and I hope that you paused when you needed to and rewind when you need to. See you soon.